welcome back to the eighth part of hacking my productivity. I'm really excited for today, as we will be working towards improving some of the metrics that we've been creating over these last couple weeks. So if you go look at part 7 or any of the earlier ones, you'll notice that we are taking data from a brain activity headset. We are then looking at how my focus changes throughout a programming session, and we're counting the number of distractions, and we're creating an efficiency score. And now I want to push this into production so that some of the Neurosity users are able to take advantage of these new metrics and this new analytics data. And there's some cleanup that I want to do, and I'll go in and explain why. But we'll be using pretty much pure JavaScript to run some analytics over this data. I'll walk through what we did. We'll refresh what we did last time to get this to work. And we'll keep this as a pure JavaScript function. That means that it takes input and always produces an output in the same way. It's important that we write functions that are just producing, that are running analytics on something as a pure function that don't rely on stateful variables. They always produce the same result every single time. Very useful. And so I'll probably go ahead and throw my Notion on. So this is a device I've been using to identify when and where I write my best code. The whole goal of Neurosity right now is to help programmers find focus faster and stay focused longer. Anything we can do to help that's what we're working towards. So it just goes on just like that. See it on the side of my head. Kind of comb it around a little bit, but that's really it. Once it's on, and that's it. So I'll go ahead and switch my screen over here, transition, and we're good. All right, and so this is the developer console code, and we are working to open source this whole entire application. And right now it's not open source, but come over here, you can see, and this will refresh in a second, so give it a minute. You can already see data starting to pump in from today. And so if I go look at my data from yesterday, check this out. This was a pretty good session. Oh yeah, there's a bug we gotta fix. You know what? Let's just go fix that right now. Let's see. That is from... we were using the cache. Last time we added some data to the cache, but it turns out, and I'll kind of open back up over here. If I go, I added some metrics to local storage, and I'm traditionally local storage limits. I'm more of an application developer, less of a front-end web developer. So I didn't know this, but it turns out that the local storage is 10 megabytes of storage for objects. When you're writing a website, turns out that this metric data that we were storing to the local storage is actually like maybe a megabyte to 2. So after you cache a couple sessions, it loses it, or it overrides it. So I would like to go ahead and fix that. And so we were doing that caching. I think we were doing that over in memories. Over here. Yeah, this create persistent state. So we're actually going to, instead of set documents data, we are going to set cached documents right here. Okay. So right here we're going to, this is where we are actually messing everything up, this set cache documents. So if we look right here and we console log previous, and Control J. We go look at this, you can see that previous docs, there's 5 different documents here, or there's a number of them. And I think since this is cache, we could probably eject the, you know, eject like the oldest ones, so that if we refresh this, I know this date is cached, so if I click here, you know, it'll immediately pull that one from cache. But if I click back to here, it won't be able to fill that in. So I think the idea is that we delete the oldest day from cache. And I just want to look at, so selected day. I want to look at how click this, it should crash. No? Oh, okay. Oh, that's okay. If I click here, it will crash. Dun, 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 crash. Cool. That's okay. Look at this. Alright. So how could we look at this list by keys and eject the oldest one first? So 327. And even then, it's like, how do we know how much we need to eject? That's a good question. I think for now we'll probably just cancel this out and not save to cache for just a little bit. Let's focus on counting the distractions. Okay. So I should be able to at least click on this again. Okay, so this is my data from yesterday. You can see it's pretty interesting. So you have this pretty solid chunk of data. And this is based on the gamma wave, so it goes up and then jumps down and then it slowly rises up and then it comes, it shifts a little bit and then it rises back up a little bit again. And we've counted here 127 distractions. And I just don't think that's true. I'm pretty sure it's counting a lot of this data down here as distracted time, whereas these dips, these big dips down here are really what I want to count as the distractions. Like this, these. So I want to spend a little bit of time fixing this up a little bit, because I think it will present a big opportunity for us to improve you know, how this is all calculated. So if we come back over here and we take a look at where is it? Memories. Let's see. Analytics. Yeah, we created a new function called, or a new file called analytics. Don't need this. Okay. And this is the session. Okay, get metrics productivity data, get sessions. Get session jumps us down here where it tries to identify the sessions. That's good. Don't need that anymore because this is working. Right here is where we get productivity stats. So this function should really be below get sessions. Okay. So let's look at how we were doing this, right? So we were calculating an average focus value. And then based on that average focus value, we were counting the number of distractions. Just based off this idea as if the current metric dot probability is less than the average focus value fixed, we would consider that significant, and we would say that we are not focused. Okay? Now, I think that what this is doing is it's counting a lot of this data down here as distracted. And I don't really think that's the full picture, because you can tell that there's not dips, it's just that my focus activity was not as good. And I'm trying to think to myself, how can we use that to our advantage, right? Like, we know here it's very obvious that this is a distraction, right? But over here, it's more of a question as to why is this gamma power less. So I would really like to understand and sort of approach this more. And the way I've been thinking about doing it for the past couple of weeks, since I made this original metric, is can we do like a rolling buffer, something like that? I think would produce a better result. And what that would look like is you're looking at the last 5 or so metrics, maybe the last 20 metrics, and you're saying like, are you falling below a number? Is there a significant change? Because if that was the case, we would count, this as a distraction, and then you'd come back down here, and you'd count this, and then you'd level back out, and you'd count this as a distraction. And I think it would be a little bit better of a entire system. And even here in the calm data, I think the calm data is sometimes a better representation of distraction. And it's really interesting looking at the difference in calm versus focus data. Calm is based on that alpha wave and can generally work a little bit better. So we could even try running, instead of using focus to drive this, the gamma activity, we could try using calm to drive it and see if that produces a better result. Using the same algorithm could be something we try. All we would have to do that is just change this to calm. Why is my computer sounding like it's on fire? Google Chrome. Yeah, that's okay. Okay, just checking my tasks. Alright, so now if we come over here, we see we are using calm data as our driver. And if we go click yesterday, already does seem to be a little bit more stable, honestly. And if we count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 30, 40 distractions. I still think it's overcounting a little bit. It does seem to be a little bit better. And there can certainly be some similarities in this data, but you can see that there not always is. Like here, and here it's pretty obvious that there's a big change in the data, and that's essentially what this is measuring. Is it's really dependent on change. If something's changing, then it'll rapidly call that, or at least be relative to that. So let's just try playing with the rolling buffer. Let's go for it. Okay, so I think it's sort of this metric dot probability that I think we need to think about. Um, and this could be pretty simple. I mean, there's a million ways to do this, and I really think RxJS could be a better way to approach this. But let's just say um, const rolling buffer is equal to an array, and we'll say const buffer size and we'll have it equal to 30. And then we could say something like this, where we let's see here. I mean, obviously we could push metric dot probability. And of course, if you have any questions, please feel free to enter that into the live chat, and I'll be happy to answer it. So we have const probability, and we'll say rolling buffer dot push, probability, and we can say if rolling buffer dot length is greater than rolling buffer size, then we want to do rolling buffer dot pop, and that'll push one out of the front. So real quick, push and pop. If I add another one here and I go node and I go let r equal this, and then we do something like r dot push 1, it's now is an array of 1, and if I do r dot pop and I print array again, it's going to be an empty array. And I think there's a better way actually. Let array 2 is equal to array dot, I think that would, from, and then you enter a length or something, and then you do fill 0. Is that how you do it? Array 2? No. How do you do that? Fill array with zeros JS. Let's see how we initialize an array with a number of values. JS. Yeah, that's it. Let R2 equal new array 3 dot fill 0. Yeah, that's how you do it. Okay. So we're actually going to move this line down here, and we're going to do is equal to new array of rolling buffer size dot fill 0. Perfect. Okay. So now we're going to have at least an array of 30 numbers that has all 0 in it. And maybe we don't need to do this. Array dot push. Let me just try this 1. It might not actually be the right thing. Push 1, and if we pop, and we print this out. Alright. Dot pull. I thought there was a way to shift. That's the right. All right, shift. Okay, so that's actually what we want to do. We want to do shift, not pop. Pop will pop off the last one. We want to do shift. Okay, and I don't think we actually need to do that. That new array initialization. We can, it's cleaner, but it's okay. Okay, and now we want to do something similar to this, where we calculate the average focus value on a per buffer basis. So we say like const average focus value, and let's actually just cancel these out for a second. Probably end up taking this though. And instead of going over metrics, we're going to do over rolling buffer. We don't need a map here anymore. And we're going to do... I may want to do this just for safety. Alright, so before we do anything else, I'm getting yelled at for this. Alright. Let's go look at that data from yesterday. So we lowered the number of distractions by a little bit, but not entirely. I'd like to see what happens when we, let's just comment this out for a second. And we'll, I'm going to write this number down. Alright, so, let's see, 71 distractions, still a little high, with calm, and then with focus data, we are at 127 distractions. With focus, and then with the new code, let's go see what we got. Just want to clean those up. All right. So that really helped. So we went from 127 distractions to 72, which I think is probably a closer to realistic number. But I guess I'm really looking for like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I guess that's pretty bad. 15, 16, 17. It's really the deviations that we're trying to count. So still a little high. So let's see what we can do. I think let me just record it. 72. 72 with focus. So we've definitely improved it a little bit, which is good. The issue that we're going to run into, though, is that as we lower the number of distractions, the efficiency score that we're currently calculating is going to go up. There's going to be an issue because the amount of lost time is going to go down. But we can certainly add some padding around the distraction periods, which could help. Let's see. What do we want to do? Average focus value. I mean, let's see what happens when we, for one, like just go ahead and do. I would like to calculate this one day. That we're working with. Alright, and then comment that out and implement the cache stuff again. Okay, so we go to analytics. We could certainly lower the buffer size. I think it'd be cool to print out the average focus value for a little bit. Let's just see what this looks like, actually. definitely a lot of values. Alright, so that's at the end. Let's see how this starts. Starting lower, high. Okay, good. This is exactly what I want to see. So maybe we don't need to fix it anymore. So we start off here, and we're high, 20, 30, 33, 34. We're up there. Anything below 25 is going to be considered distracted. There's really a better word for that. It's not fixed, it's distracted value. It's really like dynamic const dynamic distracted value. It's really dynamic is distracted value. Let's call it that. It's prettier. Okay, I don't need to rerun that, but let's just for a second say, so what that's doing is it's creating a moving threshold that it will consider if things are distracted. So for this one, for like this current session, we're actually getting some decent data. I agree, I'm pretty focused. So this is for today. We have our gamma start to rise. It always does this. It rises and then I get into it. Let's see. Okay, so we have this dynamic is distracted variable, which is half of the average focus value. So we're taking a bin of 30, we're taking the average we're averaging that number together, and then we're cutting that number in half, and we're saying if the current point is less than half of that, is less than that halfway point, then you are distracted. And that's producing 72 distractions for this current period. And really it shouldn't be that high. And I'm pretty sure if we took like this value, and then we say A, or we say B is equal to A minus A times a number, 0.5, right? That will cut it in half. Why are we subtracting that again? That's weird. Well, I don't think we need that A minus thing. Anyway, we have let's see what happens when we lower this. Certainly lowers the number of distractions, eh? It's the plotting that takes a while. It's not loading it from the database. It's interesting. I'm just writing a note to myself to fix the plotting. Okay, so our number of distractions is actually like way better now. Probably more realistic, but that score of 99% is what's problematic. Wow, this plotting is insane. This is really needs to be fixed. 33 distractions. So we've gotten it from 127 distractions to, well, I guess this is today, to 33 distractions. I mean, this was this literally was a terrific programming session. So this may not be the best example because it really felt like it did feel like a 99 out of 100. So this may not be the best example. I mean, I was solid working. Go check out another one. It's weird it does that double draw. I don't know. Yeah, it seems like the timing is a little bit bad now. So I mean, look at all these distractions. I think we need to penalize distractions more in our like efficiency slash lost time estimate. Because I really like where the number of distractions are. I mean, that really is a much cleaner number, 20. But what I don't like about that is the amount of time focused. So how did that work? I remember this. Okay. So we're calculating the amount of distracted time. I mean, if we did something like metric dot timestamp, if we penalized each distraction with like, I don't know, there's gotta be a better way to do this. Let's see. If we penalized the start time and we made the start time farther back in time, see what happens there. Just want to see how that reacts. Every time there's a distraction, you lose 10 seconds. It's kind of interesting. Like you just automatically lose your deduction. I don't know. I don't like hard coding that. It doesn't seem like the right way to do it. But I'm pretty sure it would give more truth behind it. Yeah. What about my current session? Okay. And this is something as simple as like const distracted time penalty equal to 10 times 1000. Something more like that. Every time you get distracted, you lose 5 seconds. I don't know. Well, I'm pretty sure the research shows that it's actually much more than 5 seconds. So that could definitely be a good to do. I mean, I think it says like it takes minutes to get back into it. Let's just start with that though. I don't think we need to plot this as much anymore. I don't even know if we need to plot that. Also got some feedback that we don't need minutes here. Say something like else min's greater than 30 question mark, then min's plus 1 else min's plus get min's. So at least we're rounding up. Okay. All right. And let me go through and feed this with Calm. I want to check out how the data works for yesterday. gotta clean up this loading. I may spend the rest of the day today focusing on speeding up this drawing. So it's brutal. And this is from yesterday, right? April 23rd. Today's the 24th. Yep. How do we feel about this? Man, this was a pretty good work session. One, two, three, four, five, six, seven. So 1, 2, 3, 4, 5, 7, 10, 11, 12, 13. Seems a little high. Probably right though. Okay. Let's just freeze this for a second and let's go see if we can speed up some of this plotting. Chart data. Reduce. Metrics dot sort. So we're sorting them by timestamp, and then we're reducing them by labels. So how do I pick like every 6th one or something? Well, I don't know if I want to do that. I want to average them or something. Something like. And it would be by label. I don't know. I'll have to ask Alex what the right way to do this would be. So that's where the label's coming from. Timestamp. Okay. I wonder what the right way is to reduce the number of labels. Well, it's really only when there's like a certain mass of them. Get chart data and you're sending it labels. There is a selected metrics. I'm not sure what the right way to do this is. Okay. What is this called? React chart JS. Let's go check out this project and see if there's anything we can do with the rounding. Scatter charts. Okay. I don't know if there's gonna be. It's not really what I want. Is there a docs? Donut example, line example. Oh yeah, I wish we could do a line, not a. I think we are doing a line, but. This looks very curved. What is sales? Let's look at sales. Mixed data example. Sales is the line. I wonder how they get it so that it curves around like that. It's definitely a type line. Let me go look at what we're doing over in our code. So ours is definitely, you know what? Ours is a line, but it's connecting it's showing the dots for the line. I don't know how I feel about this whole thing. Okay, for now, let's just go put focus back in here. I think this is a little too sensitive now. The time penalty is a little bit big. So we made it harder to count as a distraction. Actually looks pretty good. Okay, so I think we're at a pretty good place. I definitely want to figure out how I can lower the number of lower the time it takes for each graph to be drawn when I click on another thing. And I want to clean up some of the CSS using a flexbox. So there's a good chance that I can try and use some code that Alex sent me to make this a flex box, and I think let's just go ahead and try and clean up some of the CSS since there's a little bit of time. So Alex sent me this code, and it comes from this styled components. So I haven't done any of this yet, but let's give this a try. Inline switch. I don't think we need that. Oh, that's really cool. This is how the switch works. So tooltip props. Let's just try coming over here to session. Now essentially we want to do something like this, where we say the box and flex components both accept an SX prop that works with no additional setup required. Okay. So I can't stress enough, I have no idea what I'm doing, so let's just have fun with it. That's why we do this, right? We have fun with it, and we experiment quickly. So we're gonna move session up here. I think we actually want to do a box. Something like this. And then we want to copy all of this. Put this over here. And then get rid of this. Definitely want to put this back up here. Something like box. Once again, I really don't know what I'm doing. I don't know if you need that aside thing. Let's honestly just see what happens with that. Doesn't look like it's gonna work, but. Okay. So someone is mad at us. Oh yeah. Should have automatically been fixed. Boom. Okay. That's at least a little bit better. It's not mad at me for a second. Wow. That's intense. So I don't think that really worked exactly how I wanted it. Um, let's go look at how we set the width for this. Okay. What is this? Just go put this in here. Bet this will do it. I don't know what this 1.5 thing is, but we'll read about it in a second. It's just box. That's it. P5. What is that? Oh, that's the height. Okay, width 1.5. Interesting. Oh, definitely don't need to save that. Does it seem wider? Alright, let's just try this. Get rid of these. See what that looks like. A whole lot of nothing. Alright, there's some error that we're gonna see. No? Alright, there we go. Wow. Well, that got intense looking. Guess we really want this over here, underneath this box. I would really like to figure out what this width thing is and the height is. One. How do we find that out? Width. So there's two boxes now. wonder how I get this box to go over there to the right, though. You know, that's kind of my question. Oh no. Card demo. Look how nice that is. Theming. Composition. You can use rebass components out of the box with larger composite components. Export default box width 256. They're like pixels? It's not pixels. Heading as H3. Well, that'll be useful for one, but alright, let's see if this is getting us closer to what we need. We can get rid of this. H4. And we can get rid of this box. Still don't know what this width thing is. What's going on here? Look at that. How did they do that? Heading, CSS grid. Grid gap 4. Man, I really need this SX thing. I don't know what that is. Wow. Okay, did not like that. Is it consistent? Yeah. Let me actually go back over here. Where are they getting heading from? I bet this doesn't exist. I had to guess. So let's try this. Instead of this width thing, doesn't seem to be helping anything. Let's put that in. There's pulling header from that. Interesting. H3, let's do H2, put that there, put that there. Just trying to make it look a little bit better. Get rid of these little, see what that looks like. Well, it's brutal. Oof. Guess I could try. Just leave it there for a second. See what happens. I don't think this is gonna work though. I'm gonna need to come back tomorrow with a little bit more help. See what we can do. I mean, kind of losing focus a little bit here. My data kind of shows that too. You can see a slow, steady decline in my focus data. Alright, well, it does not look ideal, so we'll come back tomorrow and we will recode this and we'll get this CSS working correctly and we'll go from there. Let's see. So overall, we've been using the Neurosity Notion headset this whole time to track my focus, and I started sort of draining off at the end there, and I think the data really shows that as well, as it has that nice gradual dip. Definitely hit a couple struggle points today where we weren't able to get that CSS worked out. I'm not very good with CSS, Flexbox, or any of that, so I'm really looking forward to learning how to do that a little bit better with React, especially. Although this just seems like some standard HTML, CSS type stuff, and getting everything to work out correctly. And I think it'll be really good once we get it all working. I think we'll probably also spend some time and try and clean up that graph. But overall, we did clean up the distraction counting. It's much more accurate, it seems. And so I'm going to keep playing with it. I'll keep using it every day to keep measuring my distractions and see if we're getting closer to this actual underlying truth of, how much lost time am I having due to distractions. So thank you very much for tuning in. I'll be back tomorrow probably, or the next day. I'll post on my Twitter at Andrew J. Keller, and you can follow me there and see when I come out next, or subscribe to Neurosity's YouTube channel below to be notified when we stream again. So thank you very much, and I hope you have a great night. And take it easy.